Hello students, in this video we'll find the probability of independent and dependent events. Let's get started. First, let's talk about independent events. Put simply, independent events are events that have no impact on each other. Like when you flip a coin and roll a die. The coin's results have no impact on the die, and vice versa. Let's try an example. You flip a coin and roll a six-sided die. What's the probability of flipping heads and rolling a 2? To find the probability of these events happening together, we need to calculate the product of their individual probabilities. Remember, probability is equal to the number of favorable outcomes divided by the total outcomes. The probability of flipping heads is 1 over 2 since there is only one way to flip heads and there are two possible outcomes. The probability of rolling a 2 is 1 over 6 since there is only one way to roll a 2 and there are 6 possible outcomes. To find the probability of both of these events happening together, we need to multiply their individual probabilities. So let's multiply 1 over 2 times 1 over 6. To multiply fractions, we simply multiply across the numerators and across the denominators. 1 times 1 is 1, and 2 times 6 is 12. The probability of flipping heads and rolling a 2 is 1 over 12. Next, let's talk about dependent events. Put simply, dependent events are events that have a direct impact on each other. Let's try a problem like that. You pick a card at random. Without putting the first card back, you pick a second card at random. What is the probability of picking a 3 and then an even number? These events are dependent because once you pick the first card, that card is no longer available to pick as your second card. The first event affects the second event. In general, choosing items from a group and not replacing them creates dependent events. To find the probability of these events happening together, we need to calculate the product of their individual probabilities. The probability of picking a 3 is 1 over 4 since there is only one number 3 card and 4 total cards. Now when we go to choose our second card, there are only 3 cards left to choose from. There are 2 even numbers left, 4 and 6. So the probability of picking an even is 2 over 3 since there are 2 even cards out of the 3 remaining. Now we need to multiply these probabilities. Let's multiply 1 over 4 times 2 over 3 by multiplying the numerators and denominators. 1 times 2 is 2, and 4 times 3 is 12. 2 over 12 simplifies to 1 over 6. The probability of picking a 3 and then picking an even number is 1 over 6. Let's try some more examples. You flip a coin twice. What is the probability of getting tails and then tails again? To find the probability of these events happening together, we need to calculate the product of their individual probabilities. The probability of flipping tails is 1 over 2, since there is only one way to flip tails and there are 2 possible outcomes. The second coin flip is also 1 over 2, since the first coin flip has no impact on the set of outcomes. Multiple coin flips are independent events. Now we'll multiply 1 over 2 and 1 over 2 by multiplying the numerators and denominators. 1 times 1 is 1, and 2 times 2 is 4. The probability of flipping tails and then tails again is 1 over 4. Let's try another one. You pick a card at random. Without putting the first card back, you pick a second card at random. What is the probability of picking a prime number and then a prime number? The probability of picking a prime number is 4 over 6 since there are 4 prime number cards and a total of 6 cards. To help figure out the second pick, let's say number 2 is chosen. After the first pick, we now have 3 prime number cards and a total of 5 cards. So the probability of choosing a prime on our second pick is 3 over 5 since the first pick impacted the number of cards to choose from. Notice this wouldn't change if we chose 3, 5, or 7 on our first pick instead of a 2. Choosing items from a group and not replacing them creates dependent events. Let's multiply 4 over 6 and 3 over 5 by multiplying the numerators and denominators. 4 times 3 is 12, and 6 times 3 is 30. 12 over 30 simplifies to 2 over 5. The probability of picking a prime number and then a prime number is 2 over 5. Let's do one final example. You pick a card at random. Without putting the first card back, you pick a second card at random. What is the probability of picking a 3 and then picking a 3? The probability of picking a 3 is 1 over 5 since there is one number 3 card and a total of 5 cards. After number 3 is picked, we now have 0 number 3 cards and a total of 4 cards. The second pick is now 0 over 4 since the first pick impacted the number of cards to choose from. If you've been multiplying fractions for some time, you might know where this is going. 1 times 0 is 0, and 5 times 4 is 20. 0 over 20 simplifies to just 0. The probability of picking a 3 and then a 3 is 0. If you think about it, it makes sense that the probability was 0. If any single event in a set of events is not possible, then the entire set is not possible. That's it, students. Remember that independent events have no impact on each other and do not change future outcomes. On the other hand, dependent events have direct impact on each other and change future outcomes. Good luck with these problems, students.